it's going to send columns of cytotrophoblast cells down. In the meantime, the maternal blood is opened up even more, so all of this is exposed to additional blood supply. And the cytotrophoblast will change to fetal connective tissue. And we'll have fetal blood vessels. So we have maternal blood now available out here, and we have fetal blood vessels. And this just gets, like you saw in the video, this branches and sub-branches and sub-branches until we have very small, like I said, little rootlets appearing. All of them having a core, a surface of syncytial trophoblasts, and then some scattercytal trophoblasts, and a core of fetal connective tissue and fetal blood vessels. And this is how we would have maternal blood here. And oxygen would cross the syncytial trophoblasts, cross the fetal connective tissue, cross the simple squamous epithelium of the fetal capillary, and then we would have oxygen in the fetal capillary coming together to form the umbilical vein and going back to the fetus as oxygenated blood. It's called a vein because it's going back to the fetus's heart, even though it's oxygenated. So we see, again, these small villi developing all around, but only at the side of the inner cell mass as it developed very complicated chorionic villi. In the first, so with my twins, I was 38 when I got pregnant, and they, with that age, they wanted to do an amniocentesis, which in fact is how I found out that they were twins, because the ultrasound showed two babies and they had two sacs that they had to go through. That was done about that was done at 14 weeks, okay? If they need to do earlier tissue sampling, if they're worried about some genetic disorder, and they need to do earlier tissue sampling, say around 6 weeks or 7 weeks, this isn't developed enough to risk harming the embryo by going in taking a sampling from the amnion. That cavity is just not very large where the embryo and amniotic sac are. So they will go in and they'll do chorionic villi sampling, which can give them the same genetic information because it's still the fetal cells, okay? They've just differentiated into chorion instead of the embryo. So they can still get the same genetic information. All right, so we have the chorion. As I indicated, that's fetal tissue and carries fetal blood vessels out into the chorionic villi. So we have the chorionic villi and chorion levy. And this is a cross-section of more mature, probably 7 to 8 month chorionic villi. So out here is the syncytium, it's kind of orange-yellow. These little cells here are cytotrophoblasts. All of this is fetal connective tissue and fetal capillaries with an epithelial lining and a connective tissue on the outside. And maternal blood would be all in here. All right, because it's kind of suspended in that pool of maternal blood. So in this image here, you can see that all of this would be a stage of chorionic sampling because they all look very similar in length. But now you can see that there's a difference, like I drew on the board. And so we have the longer, this is kind of the reverse of the way, not kind of, it is reversed in the way I drew it. So on this side is the actual developing placenta with chorionic villi, and here you can see the chorion levy, okay? Just not as well branched. And this is what I meant by the embryo remaining implanted within the uterine wall. And as the embryo and fetus grows, it bulges out into the uterine cavity. The surface of the uterine lining moves to the opposite side. So the uterine cavity doesn't become filled In other words, it's not contacting the amniotic membrane of the placental sac, but the uterine surface that was on this side. So let me draw it over here. So we start out with basic uterus. Okay, in our uterine cavity. And the embryo is here. Then as the embryo grows, as the embryo grows, it bulges out like this. And now this cavity is getting smaller and smaller. Until it is almost completely obliterated. So that never completely fuses. And we have uterine surface epithelium against uterine surface epithelium. So we have two regions of fetal tissue, the well-developed chorionic villi and the lesser developed chorionic levy. So here would be the chorionic villi of the placenta. Here would be the chorionic levy that is just under the endometrial layer that's been bulging out. We have three regions of decidua. Remember the stratum functionalis? We now call this decidua, as the fibroblast cells have swelled out. The decidua, deciduous basalis, is this region here that is directly associated with the chorionic villi. It's the source of the spiral arteries that have been exposed, and so in this gap here, this is all filled in with maternal blood. So these are the well-developed chorionic villi. This is the stratum functionalis, all right, that is deep to that and associated with it. And those arteries are opening up into this space, the lacuna, and bathing the fetal chorionic villi. Over here is continuous, and so that's known as the decidua basalis, associated at the base of the placenta. Okay. Now, this was the chorionic villi, and over here we have the chorionic levy. Remember that uterine tissue that was right above it? Let me redraw these diagrams here that would illustrate that a little bit better. I'll leave that black. That's the uterine. That's the developing. All right, so this would be chorion villi. This would be the chorion levy. And now the fetal tissue immediately deep to that is the decidua basalis. But we also have the stratum functionalis that is being bulged out into the uterine cavity, right? So that is known as the decidua capsularis. So at the bottom, where the placenta is, but it's over the top. So this is the decidua capsularis. Where else do we have decidua? On the other opposite side, right? Over here. So this is going to become the decidua basalis. This is going to become the decidua capsularis and will grow out, and all of this opposite side is the decidua parietalis. Remember, I'll show you the previous image. So now we have this stratum functionalis over here, and this is the decidua varietalis. Yes?
What does that say on the top?
Chorion levy? I just have the L and the E ran together, the L and the A ran together here. So now let's go to the previous picture. Look at that a little bit. Okay, so here's that growing embryo. Here is the chorion villi, and as we follow it around, there are very few villi. That's the chorion levy. That's fetal tissue. Chorion is fetal tissue. Then we have the stratum functionalis associated with that, again, the same one that I showed you right here. All right, so that is decidua basalis. When the placenta is delivered, if you've had children and you've seen their placenta, what we see as the placenta is both of this. It will have the chorion villi surface, the fetal surface. You won't see the chorion villi because remember, separation of the placenta occurs between stratum functionalis and stratum basalis. And that stratum functionalis is going to remain part of the placenta. And so I'll show you images when we turn that over, we're seeing the decidua basalis. All right? So now we have this uterine layer, this surface right here, that's bulging out with our developing embryo. So here it is right here. And that is the decidua capsularis. Then we have this opposite layer of stratum functionalis not involved with implantation. And as the embryo grows, this whole structure is increasing. And remember I showed you how it obliterated practically the uterine cavity? So this is the decidua varietalis. And in this view, it's this layer right here.
So it's just the other side.
So it's just the other side that the embryo is, the growing embryo is bulging towards. But it may touch, but it's still a gap. It doesn't fuse. Okay? So now if we look down here, this is doesn't have a baby in it, obviously. The umbilical cord is separate. So when we talk about embryonic development, we'll be talking about the amnion. Remember that's what came from the inner cell mass? Okay? That's what forms that's the fetal membrane that has to be ruptured. And someone showed me a picture of a baby born with its amniotic sac yesterday. I don't know if it was your class or the second one. That's the membrane that holds the fluid around the baby, the fetus. So that's the fetal structure. Then just outside that, we have the surface of the chorion villi, the surface right here. So here would be the amnion covering that surface, and then we have the chorion tissue that came from the trophoblast. All right? And then out here we have the chorion levy, and attached to that would be the decidua capsularis. And out here is the decidua varietalis. So sometimes to get labor going, one will say, my water broke. Well, water doesn't break. What is meant by that is really a quaint term. What is meant by that is the membrane's ruptured, and the amniotic fluid is released, and that usually starts a 24-hour window that the baby needs to be born within or is at risk for infection developing. Right? So if labor doesn't start within that 24-hour window, the physician's going to give Pitocin or oxytocin to get labor going. But typically it does. All right? If the woman is not, has contractions, but they're just not coming along, and the membranes haven't ruptured, sometimes the obstetrician will use a crochet type hook and rupture the membrane or tear the membrane to cause the sudden loss of fluid and start labor at a stronger, more rapid pace. So which of these membranes would that crochet hook penetrate? You want to do this to yourself, by the way, because it's to be sterile and all of that.
The capsularis or amnion?
Let's see.
So the amnion, definitely.
Capsularis.
Decidua capsularis. The chorion levy. We don't want to do the chorion villi because that's the baby still getting its nutrients through that. Decidua parietalis?
Why?
No.
No.
Oh, okay, I was like, why?
I was asking.
Oh, okay.
So your response was good. So again, if we look at this image, here's the cervical plug of mucus has developed, all right? So passing up through here, the first layer that instrument would get to would be the decidua capsularis, and then the chorion levae, and then the amniotic membrane. Yes.
When they strip the membrane, is that the cervical mucus that they're,
It's, so,
okay. Because I thought that there was like they could strip the membrane, my sister recently had a baby and I thought that she said they could strip the membrane, but they didn't break her water, that was,
It's a new thing
That's
that
like
they
in the
started
physician's
doing.
office.
I was gonna say, I haven't.
They do it in the doctor's office, they scrape the membrane and it like starts the hormone release. They did it to my cousin. when she
That
was
would,
pregnant.
that would be this would be the only access they would have, membrane they would have access to, so I don't know if it's this surface or this surface.
It works.
But yeah, I haven't, usually remove all the membrane, so if there's a question here.
No, I was gonna say, I think it's cervical scraping is what they do when they're trying to move it along. Because usually it's when you're dilated only a little bit,
And then
and
nothing
then
else
they're
is.
trying to
Okay.
move it along, so I think.
What happens when labor starts, well, not labor starts, but in preparation, when we talk about dilation and effacement. So effacement is thinning of this cervical wall, all right? Dilation is the increase in the diameter of the cervical canal. So a woman can be dilated but not effaced, or the other way around. Usually they'll talk about you're ready to push when you're 10 centimeters dilated. So that's time to push. If you're not 10 centimeters yet, they don't want you pushing. So effacement is changes in the thickness of the cervical wall here, which can contribute to, obviously, to the diameter of the open cervical canal itself. So when a baby is born, all right, if it's not born in the amniotic sac, which is rare, these membranes have ruptured. The baby comes out with the umbilical cord still attached to the placenta. The umbilical cord is cut near the baby's umbilicus. And then the afterbirth occurs. And now we have separation. Just remember I talked about it's the same thing as what happens in menses. There is constriction of the spiral arteries and separation of the stratum functionalis from the stratum basalis through all of the decidua. So all along here, the decidua parietalis is going to separate at the where the stratum functionalis, which is really what we're talking about, is decidua parietalis, is continuous with the stratum functionalis. So this entire layer of decidua parietalis, and basalis are going to separate and come out. Usually you don't see separation at the amnion, but parietalis and basalis, where it's actually in contact with the uterine wall, separates and is delivered, the afterbirth is delivered with the placenta. It includes the amnion, but that part's not going to separate from chorion levies. So here are some images of a placenta, and this is fetal surface. So this is the amnion. Remember I said the chorion villi, as the amnion develops, it's attached to the surface of the chorion. So in the placenta, unless you cut it open, you're not going to actually visualize the chorion. So that grayish blue covering is the baby side of the placenta. Placenta means cake. In some cultures, many animals, and some human cultures eat it. It's a rich source of protein, and typically they were thrown in the freezer and sold to companies that made anything from dog food to shampoo. And now women are saying, "Hey, this is mine. If I want to take it home with me, it's mine to take home." And so this is the flip side, and is the endometrial surface. This is what you're seeing here, is the stratum functionalis, now the decidua basalis. They're called cotyledons. It's kind of got a cauliflower kind of appearance. So that's what you're looking at. So this is Decidua bacillus. Okay, where it's separate. I'm sorry. Decidua bacillus, where the stratum functionalis is separated from the stratum bacillus. So it's still stratum functionalis, but it's that decidual reaction and is the Decidua bacillus. So all the blood here is maternal blood. All right? And then here, this is a twin, so we have twins, so we have two umbilical cords.
Why does it look bubbly?
And that's your irregular surface where it was attached to the stratum bacillus, so it's called cotyledons. Here's the umbilical cord, which is surrounded by amnion, and a closer view of the amniotic surface. So this is amnion. These are umbilical vessels that are going into the umbilical cord or coming out. And again, maternal surface. Now, I don't know if this was photoshopped or not, but this is the placenta of a girl that was born on Valentine's Day.
It's
so
got
to
to be
speak.
Photoshop.
Like, I don't think so, but anyway, it was cute. Since we're getting close to Valentine's Day. All right, so we're going to go through this again. We have just a few minutes, but to get started on the embryonic development, and then we'll finish that on Tuesday. But those terms that I had with the fetal development, I want you to understand the chorion villi, chorion levi, the three layers of the decidua, and the difference between trophoblast and cytotrophoblast. We're going to look at these same images again, all right, but focusing on development of the embryo itself. I'll post some videos that you can watch, and I wanted to do that last night so we would have a preview of what we were going to cover today, but I didn't get all of them posted. So now we're back to this view. May I raise the screen, you guys, on the board? Let's get that last bit. Let me turn the light back on again. Now we're going to focus on the inner cell mass. All right, I'm not going to deal with all the villi. And so as the blastula enters the uterine cavity, you can see that inner cell mass in the upper right. And so here, as it's embedded, we start out with our blastula and just a cluster of cells that really we can't see much difference. There is a single layer that is attached to the cytotrophoblast, and then a bunch of other cells associated with that. Okay? And that's the inner cell mass. As implantation is occurring, you can see that we're also seeing a change in the inner cell mass. A separation occurs. A second cavity is forming. And so, focusing just on that, we have a layer of cells that still remain associated with the trophoblast. So these are the trophoblasts or cytotrophoblast at this point. And we don't use the word cytotrophoblast until the syncytium appears. We have this gap, and the cells that are attached to the trophoblast are going to form the amnion. And the space between them that I'm going to form in just a moment is known as the amniotic cavity. The other cells that didn't form the amnion form, what I want to use here, form the embryo. And the embryo starts out as a two-layer disc. Remember the oval shape that we've been talking about with the nerve development? So this forms a two-layer disc, creating, closing, if you will. It's within these two layers that we have the amniotic cavity. This layer is known as the hypoblast. And then the top layer facing the blastular cavity, I've done it the wrong way. Relabel it. This is the epiblast. Sorry. That's the top layer. And then the second layer facing the blastular cavity is the hypoblast. Right? So all of these cells are going to form these three layers. And the hypoblast and the epiblast are going to become the embryo. The epiblast will turn into our ectoderm and mesoderm. And most of our endoderm and the hypoblast will form part of the endoderm and other structures. So now I'm going to rotate this arrangement to match what's up on the screen. And we have our amnion. Amniotic cavity, our epiblast cells, and our hypoblast cells. Okay. From the hypoblast cells grows another membrane sac. So we have the amniotic sac, and we have the yolk sac. And that grows down into the space of the blastula.
What
The yolk sac. So let's stop here for a moment to get a better idea of what you're seeing from these diagrams. So here is that bilaminar disc, the epiblast and the hypoblast, which are going to become ectoderm and mesoderm and endoderm. Here is the yolk sac that's been cut away so you can visualize this, and the amniotic sac. All right? So if you look up on the top screen, it's as if our embryo now is this flat oval paramecium kind of thing with a balloon on its back. Okay, that's the amniotic sac. So again, this is the balloon. This is the cut edge. This is the edge of the embryo. None of us have little, vestigial remnants of that balloon. But essentially, as if I had a big bubble, I'm an oval disc, and I have a big bubble that starts from here, comes off here, and just completely fills the top of my back, and another bubble from the front. Right? amniotic sac and yolk sac. Now, we'll finish this on Tuesday, but what happens, this is the groove that forms as the cells are migrating in between the two layers. But we still just have a disc